In part 1 of analysing two time series, we went about incorporating a function that was able to read an Excel spreadsheet of published time series data and convert that into a Pandas data frame with valid variable names for the column descriptors. These valid variable names could then be used in SAS and other statistical packages. I then went through and explained the parameters of this calc_pct_plot function. I will now go on to explain the main core of the function and how it works. The first two lines after the function parameters are global PCT_dataset1, global PCT_dataset2. The reason I do that is any variable or data frame created within the function is local and can't be used outside of the function. However, I want to be able to use those percentage change datasets I create, so I need to tell Python that they'll be global variables. The next step we need to do is to subset our data frames for the time span that we want to do our percentage change for. So to do that, we simply set our data frame, in this case dataset 1, equal to open square brackets start date 1 colon end date 1 close the square brackets. And that will subset the data frame just for that period. And then in Pandas, there is a percentage change method, and it's simply PCT_change. And you set the periods on which you work out the percentage change. So if we're doing it quarterly and consecutive quarters, then the period would be set equal to 1. And I do the same for the other time series dataset, which is why we have dataset 2 and then PCT_dataset 2 as well there. And these have been defined as being global, and you need to do that at the beginning of the function before you actually specify the percentage change datasets. One of the things I discovered is that the Pandas percent change method does not multiply the end result by 100. So to fix that problem, I use the lambda function to multiply all my columns by 100. So here we have PCT_dataset1 is set equal to PCT_dataset1 dot apply open round brackets lambda space x colon space x times 100 close the round brackets, and that will multiply all the results by 100 to give us a true percentage change and not just a proportional change. So we next check to see if we want to invert either of the two variables. So if it's yes, then we create a new variable in the Pandas data frame by just simply specifying the new variable in square brackets here. So we're going to call the new variable inverted plus variable 1, and then equal to the existing variable times -1. So we use the apply lambda function to do that to that variable, particular variable. You may notice this backslash. The reason for doing that is so that we can go on to the next line and Python will still treat that as being just one line. Why we do that is to comply with the PEP 8 style guide, which requires our lines of code not to exceed 80 characters in length. The next part of the code is to do our graphing. So we're using the matplotlib libraries. So first off, we set the size of our graph, and to do that we use the command plt.figure open round brackets, fig size equals 15.5, comma 8. So that's 15.5 inches by 8 inches will be the size of our graph. Next we actually do a subplot. The subplot that we're doing here is for our legend. We'll put like a box around the legend that we put inside. And so it's a 1 by 1 subplot, and it's only one of them, so that's why it's the first. Then we set the size of the date tick marks on the x-axis, and so that's done with AX.tick underscore params, open round brackets, label size equals 9. And then we set the tick mark format, and to do that we use plt.gca, open round brackets, close round brackets, dot x-axis dot set major formatter, open round brackets, mdates dot date formatter, and %y means we'll use a two-digit year instead of the 4-digit, which is obtained by using a capital Y, and then the month. Then we set the intervals of the minor tick, the intervals of the major month tick marks, and that's done here. So we've got interval equals month underscore int, and that's called month locator. Then we've got the minor locator equals auto minor locator. That runs the code that will do the minor tick marks. And so here we initialize it by ax.xaxis.set minor locator, and that will do that. So we next have the series of if-else statements. This is to determine what variable we're going to plot, as we have a couple of choices. So whether we invert the variable, then we plot the inverted variable, or whether we not do that, then we just plot the variable as is. And here, to do the plotting, it's plt.plot, and the variable name from the data frame. So this will be inverted plus variable 1. And then we add the label to that for our legend. So that's inverted plus means concatenate in this case, a space, then the variable name, the percentage change period, and then we have this plus str, open round brackets, period. Now the reason we're doing that is Python will complain if you try and concatenate a string with a numeric, and this forces the numeric to behave like a string, and so that will allow this to work. And to plot two graphs on the same graph, we just issue another plot command down here, as we have done, and again we check to see whether the variable will be inverted or not. The next thing to do is to plot titles for our graph, and we have here plt.subtitle. That must mean super title, because this will go actually before the actual title. So this will be like a subtitle here. So I don't know why they use that sort of convention, but they do in matplotlib. And so we've got the graph title and the graph subtitle, and then the font size for the title and subtitle. So we make the subtitle a little bit smaller. Then we actually specify the actual legend box. So it's going to be located upper and center. So it will actually be just below the main graph. And we have the BB box to anchor, and these are the coordinates of where this will start from, I guess. And you have options here like fancy box equals true, shadow equals true, so you have a shadow on the legend, and a number of columns. So we're going to have two variables, so we just need two columns. If you wanted them one below the other because it might be long, then you just specify one column. and then the font size. You can play around with these parameters to see how it sort of looks and whether you like the look of it. And finally, there's this bit of code here, which is plt.gcf round brackets auto fmt its date, and this automatically formats the dates on the its so they are readable. So you just need to actually do that. And then finally, to actually show the graph, all we do is issue the command plt.show. And to finish off the function, we return our percentage change data sets. So I think I'll stop there, as the video is getting a bit long now. And in the next part, we're going to actually go through the main program and then get to run it and see the end results. So if you'd like to give me a thumbs up, if you have any comments or feedback, just let me know. That'd be great. Thank you.